Hello, welcome again. We are solving GATE 2010 Aerospace Engineering paper. We are solving only the questions from mechanical engineering. Question number 40 and 49 are: consider a simply supported beam of length L carrying a bracket welded at its center. The bracket carries a vertical load P as shown in the figure. The dimension of the bracket are A is equal to 0.1 L. The beam has a square cross section of dimension H into H. So this is the figure given here. This is L, this is A, this is A. Then load P is applied. Okay. So question number 48 is the bending moment diagram is given by. So this is the these are the options. Option A, this diagram. This is 0.3 PL. This is 0.2 PL. Option B, the diagram is like that. Option C, this diagram. Option D. Okay. And question number 49 is the maximum value of shear stress is option A 0.67 P by H square, option B 1.33 P by H square, C 1.5 P by H square, and D 0.9 P by H square. So this is your diagram, and in this diagram we can apply P downward here and P upward here. It will make no difference. Okay. So now this P and this upward P, this downward P and this upward P will create a moment that will be equal to P into A, and this P will be directly transferred to beam. So equivalent diagram is this, and RA and RB are the reaction at 2 ends. Okay, so this is your P. Now to find out RA and RB, taking moment about B. So RA into L minus PL by 2 minus PA, because these are anti-clockwise, these are clockwise. Okay. So RA comes out as putting the value of A, that is 0.1 PN. So RA comes out as 0.6 P. Now total downward load is your P and total upward load is your RA plus RB. So from this we can find out RB. So RB is your 0.4 P. Okay. And finding moment. So the general equation between this between the point of application and this A is mx is for this point is C. So mx AC is RA into x. If we take x is equal to 0, then ma will be 0. If we take x is equal to L by 2, then it will be MC. So MC is 0.6 P into P L by 2, so that is 0.3 PL. Okay. Now to find out the moment, to find out the equation of moment between C and B, it will be RA into x minus PA RA into x minus PA minus this is your L. So this will be this is your L by 2. So this will be your x minus L by 2. Okay. So MC will be, so if we put x is equal to L by 2, then we get MC. So MC will be your 0.2 PL. So that is different from the previous one, because so there is sudden change in bending moment at point C. So this is without point bending moment and this is with point bending moment. Okay, and if we put x is equal to L, then MB will be 0. So the variation of bending moment is here it is linear, starting from 0, and it is which is up to 0.3 PL, and then there is a fall, sudden fall, that is 0.2, it reaches up to 0.2 PL, and then there is decrease. Okay, so this is your bending moment diagram. Okay, now we can see that the maximum value of shear force is either of RA or RB, and from RA and RB the maximum value is for RB. So RB is your 0.4 4P and RA is your 0.60. So maximum value is 0.60. So the shear force is 0.60 and average shear stress is 0.60 divided by area of that square section, that is H into H. And we know that in case of bending and in case of square cross section, the maximum shear stress is 1.5 of average shear stress. So that is that comes out as 0.9 P by H square. So option 0.9 P by H square. Option D is the right answer.